Okay. All right, we are live. So, hey everyone, welcome to Practically We Bring Learning Alive. So, as you all are aware that we are conducting this term 2 one-shot series for class 9 and 10, correct? Okay, before we begin, let me know if I'm audible enough and the screen is clearly visible. So, could you please type in the comments? If yes, type yes. If I'm audible enough. Psychological fact. Hi sir, not sir, it's ma'am. Hi Razia. Okay. Hello. Alright, so now I'm sure I'm audible because you are replying as well. Alright, so today in our mathematics class, we will be talking about or we'll be discussing about the chapter constructions. I know it's very small chapter, correct? So out of all the chapters of class 10, constructions is one of the shortest chapters, yet very scoring, because if you know how to construct something, and you will be getting marks if you write exact steps of construction, correct? So there are three topics of this constructions. There are three constructions. So we will do all the three, okay? Hi Pratik, how are you? So how was your preparation going on for your class 10 exams? I know the date is not given yet, but how are you preparing? I hope you're doing well. Okay, so do type in the comments, okay, how's your preparation going on, or what chapters are you feeling difficult in math and what chapters you feel easy in math, okay? Do type. So first let us see the schedule, okay? This is a schedule of class 10 one-shot math and science subjects, okay? And the slot is from 4 p.m. to 6 p.m. correct? And it runs from, it is begin on 1st February and it's till 16th February. Next, this is sample paper discussion. So after we complete the sample, one-shot series, from every chapter, we'll be taking some important discussions and solve the sample papers, okay? Yes, hi Razia. This is for coding and the time slot is from 8 to 9:30 p.m., okay? And these are the topics sir will be discussing in the coding classes. Next. So, let us see what topics very easy in math. Yeah, very good. I'm glad. But then you do more practice, you'll be finding it more easy. Alright. So, what are we going to discuss today? We will be discussing division of a line segment, construction of a similar triangle using a scale factor, and construction of tangents to a circle. Alright. So, these are the three, constructions you have in class 10. So, let us begin. So, but now to construct these, we need to know or we need to be aware how to construct a parallel line and perpendicular line. No, it is not class 8, it is class 10. Okay. So, Pratik, are you from class 8? Seven, you are from class 7. Okay. Alright, so yes, and the concept of construction of parallel line, but you're class 8. Okay, you're also in class 8. You're okay. Why is everyone? Alright, so I don't know why you have thought this to be class 8, but this is class 10. Okay. Fine. So let us start with construction of parallel line. Okay. So how do you do? Now this is a point A, and through point A, I have to construct a parallel line which is parallel to line PQ. So even class 8 students can answer this because we have done this in practical geometry, correct? So how do you do? Take some convenient radius. Yes, you know this concept, of course. Why? Because we've been studying this in practical geometry. Correct. So take some convenient radius, place the needle of your compass at point P and draw an arc. So I will be drawing an arc like this. Alright. So let this arc meet the line at point M. So what do? You won't change the radius of the compass. Take the same radius. Now place the needle of the compass at M and again draw the arc. Now, let us name this as point X, correct? Now, if you are aware, if I join PX, this will be 60 degrees, correct? This is how you construct 60 degrees. But how do we construct 90 degrees? Let us see. Again, do not change the radius of the compass. Place the needle of the compass at X and again draw the arc. So, now your arc will be somewhere here and let us name this as Y. Okay, wait, this is, we are constructing parallel lines. Okay, now, this is perpendicular, correct? But no issue, let us draw an arc which is at M. Now, don't change the radius. Now, place the needle at A and with the same radius, draw an arc. Okay, so what concept are we using here? We are using the concept of corresponding angles. Are corresponding angles equal in parallel lines? Can anyone answer me? Are corresponding angles equal in parallel lines? When a transversal cuts through it? Of course, corresponding angles are equal. So, if there are any two parallel lines, if I draw a transversal like this and I name this one, this as 2, angle 1 is equals to angle 2 and they are called corresponding angles. So, when a transversal cuts through two parallel lines, we say that corresponding angles are equal, right? So, here we will be using, yes. So, we will be using the concept of corresponding angles so as to find the parallel line to line PQ. Okay. Next, let's recall how to construct a perpendicular line. How to construct a perpendicular line? Again, let us see. Let me take a different color. Again, with some convenient radius, take your compass, place the needle of the compass at point X and draw the arc. Okay. And let us name this as A. Again, with the same radius, do not change the radius of the compass. Place the point at A and cut an arc. Let me name this as point P. Again, do not change the radius of the compass. Place needle of the compass at point P and cut an arc. Let us name this as point B. Okay, now what do you have to do? Again, no need to change the radius. Place the needle of the compass at point P and cut an arc. With same radius, place the needle at point B, cut an arc. So this, if I join, let us name this C. Now XC, this is 90 degrees. So angle CXY is equals to 90 degrees. Correct? This is very easy construction of perpendicular line. Correct? Now why we have gone through parallel and perpendicular lines? Because we will be using these two concepts in the further topics which we are going to discuss today. Alright. So first is the division of the line segment. What is division of the line segment? Suppose let me take this line AB. Alright. Now what is it given? I want to divide this line segment in the ratio of 3:2. Okay. How do I divide? Correct. So this is what we will be seeing now. If I take line segment AB and if I want that line segment to be divided in the ratio of 3:2, how do I do? So let us see a video for it. Okay. Come on. So division, yes. Division of a line segment in a given ratio. So in the previous example, we have taken 3:2, correct? So that is one of the examples we have taken. Now this, let us see how to divide it. So basically, there are two methods to divide a line segment in the given ratio. One is basic proportionality theorem and the other one, okay, so this is again starting. Okay, I'm sorry. Yes. So one is, okay, yes ma'am, easy. Pratik finds it very easy. Good. So let us see, okay. I'm glad even if you're 8th standard, you're understanding the concepts of 10th standard, applying the concepts of 8th. Very good. Keep it up. So the first is basic proportionality theorem. And the second one, we will be using property of similar triangles to construct a similar triangle to the given triangle by scale factor. So what is the first thing? Given a line segment AB divided in the ratio of 2:3. So we have to divide the given line segment AB in the ratio of 2:3. So first, draw the line segment AB. Okay. Next, construct angle XAB, which is acute angle. Again, what is acute angle? Can anyone answer me? What is acute angle in the comments? Yes, answer what is acute angle? Below 90 degrees. So you can say the limit is from, very good Razia, very good psychological fact, very good, under 90 degrees. So yes, we say that it is from 0 to 90 degrees, correct. So this angle AXB is an acute angle, any and above 0, very good. Now, what do you have to do? Take some convenient radius, or in general, you can take 1 centimeter. Okay? Yes, very good, Pratik. Keep it up. Good. So, take 1 centimeter. Okay? Now, if you take 1 centimeter and do not change its radius, keep always same. Do not do the compass like this and like this. It will change. Okay, your name is Rahman. Okay, I'm so sorry. Hi, Rahman. So, from now, I'll be addressing you as Rahman. Okay. So, take this 1 centimeter and place the needle of the compass at A and draw A1. With same thing, place at A1, A2, then A3, A4, A5. Correct? Now, why are we exactly drawing 5? Because when we want to divide the line segment in the ratio of 2:3, we have to add 2 plus 3, 5. Right? So, that is 5. We will be making this 5. Like A1, A2, A3, A4 and A5. Okay, let's begin. So we have made A1, A2, A3, A4, A5 where AA1 is equal to A1, A2 is equal to A2, A3. Correct? The distance between them will always remain constant. So this is one of the major points to be noted. The distance should be same, that is 1 unit. Next, now join B to A5. So, join B, A5. Next, here you have to construct a parallel line A to C to A5B. Now, this is 2 units and this is 3 units. So, here we have divided the line segment in the ratio of 2:3. Alright. So, this is one method. Let us see. Okay. So, triangle AB, A5, since CA2 is parallel to BA5. This is why in the first slide itself, I have taught how to construct a parallel line, correct? So, you can also go through, again, you can take your textbook and go through as well. So, you have to construct a parallel line at point C to the line BA5. So, you will be getting CA2. Now, the ratio is AC is to CB is equals to 2:3. Alright, or you also know that ratio you can represent it in the form of fraction. So, AC by CB is equals to 2/3. Alright, so now this is one of the methods. Now, let us also see method 2, correct? So, again, let us see steps of construction. First, draw any ray AX making an acute angle with AB. Again, so this is our line AB. And you have to draw a ray AX. Again, what is a ray? Easy peasy lemon squeezy. These are very easy, ma'am. Very good. I'm glad. So, you're understanding. I'm happy you're understanding. You're also feeling it very easy. Good. So, now, again, AB is the line segment given to us. We have to divide in the ratio of 2:3. So, this in the method 2, what are we doing? At point A, we are constructing a ray AX. So, here AX is a ray. Again, make sure that angle BAX is acute angle. That is, it should be somewhere in between 0 to 90 degrees. Alright, let us continue. Now you have to draw a ray BY which is parallel to ray AX. Okay, again, since it is parallel, this angle will be equals to this angle. Now tell me, which concept of parallel lines did we use here to construct this? If I say that angle YBA is equals to angle XAB and these two are parallel lines, what do we call these angles? Please comment please comment the answer. What do we call these angles? Do we call them corresponding angles? Of course not. We do not call them corresponding angles. What angles do we call them? All right. What angles do we call this YBA and angle XAB? Yes, of course, these are parallel lines. Very good, Rahman. BY and XA are parallel lines, correct. But what do these angles called? They are called alternate interior angles, correct. So, see, if these two are parallel and this angle is equal to this angle, what do we call them? They are alternate interior angles. Okay, let us begin. So, what do you have to do again? A1, A2, M is equals to 2 because M is to N is equals to 2 is to 3, correct? Yes. So, we take again 2 is to 3. So, in the first ray AX, again take some convenient radius, or better you take 1 unit. If you take 1 unit, place the needle of the compass at A. Okay. Yeah. And A1 and place the needle at A1 and next put an arc A2. Okay. Okay. All right. Now again in BY, you have to take 1 unit, place the needle of the compass at B and put 3 arcs with the same radius. So name them as B1, B2, B3. Now if you observe, the length B1, B1, B2, B2, B3 will be same. Alright? Alright, so same thing. You have to make sure all these distance or length will be same. Now what do you have to do? Since it is the ratio of 2 is to 3, join this A2 to B3. Okay. Join this A2 here to B3. Why? Because we are dividing the line segment AB in the ratio of 2 is to 3. Suppose if it is 1 is to 3, what will you do? Now I want the same thing to do in 1 is to 3. Can you tell me which both I have to join? Type in the comments. Okay. So, if I have to join one, like if I want to get 1 is to 3, what I will do? I will take 4, then I will be joining A1 to B3, correct? Okay, I have to repeat it again. Alright, so now I want like maybe 1 is to 4 ratio, okay? Let us say 1 is to 4. What I'll do here, I'll take 1, here I'll take 4 and I'll join A1 to B4, correct? Yes, A1 to B3. Pratik, very good, correct. So, according to the ratio, we will be joining the the points here to the points on that ray. Very good. Keep it up. Let's continue. So, now this is the required ratio, that is AC is to CB is equals to 2 is to 3. So, yes, let us see now one example. Alright, so here what we will do? We will construct, okay, AB in the ratio of 3 is to 2, correct? Yes. So, what do I have to do? First, let me draw a line segment AB. This is what we have seen, correct? So, take AB. Now, what do you have to do? I want this in the ratio of 3 is to 2. So, let me use method 2 here, and I am telling you whichever you feel convenient, you can use that method, or whichever is prescribed in the question in the exam, you have to use that method. Okay. So, first let me join this AX, and this is acute angle, and parallel to AX, let me draw BY. Now this is 3:2. That is m:(n) is equals to 3:2. So what do I have to do? Take some 1 unit radius, put the needle of the compass at A and draw an arc, cut an arc. So this is A1, this is A2, this is A3. Alright. Why? Because it is 3:2 ratio. And on the BY, do not change the radius. Place the needle of the compass at B, and this will be by B1 and this is B2. So what is now I have to do? Join this A3 to B2. Now this is in the ratio of 3:2. So AM is to MB is equals to 3:2. Hi Aman. Hello, how are you? Alright. So here we have also taken the example and we have solved in method 2, that is by similar triangles. Correct? So I hope you have understood this construction, and yes, there is also one more point I have to tell. After construction, please do write steps of construction, okay? So you can just write steps of construction as heading and write each step accordingly, whichever method you are using. If you are using method 1, write that steps of construction, method 2, that steps of construction, okay? But please make sure you write, okay? All right. Now, next topic is construction of similar triangles using a scale factor. So, what is a scale factor? Let us see. To construct a triangle similar to a given triangle as per given scale factor. So, you have to either draw a bigger triangle than the given triangle or smaller triangle than the given triangle depending on the ratio given. Okay. So, this construction involves two different situations. In one, the triangle to be constructed is smaller. So, if I give you the triangle ABC, okay, and I tell you, you have to draw one triangle which is smaller than the given triangle, okay. Now, what is other condition? We have to draw larger than the given triangle. So, there are these two conditions or these two constructions, these two situations involved, okay. Malti Sharma. Okay, hi Malti Sharma, this is the first time I'm seeing you. Hello, welcome to Practically classes. Okay. Next, here the scale factor means the ratio of the sides of the triangle to be constructed with the corresponding sides of the given triangle. So what I'll say is, in the question you will be seeing there is a given triangle. Now you have to draw or construct a triangle of scale factor 5/3. Okay, so here numerator is greater than the denominator, correct? So you have to construct a bigger triangle than the given triangle. Alright, so this is a scale factor. These are two different situations involved. Let us see. Now tell me in the comments, do you all know what are similar triangles? And are they same as congruent? Type in the comments. What are similar triangles and what are congruent triangles? Okay, no answers. I'm waiting for the answers. Yeah, so please do tell. Okay, they are same. No, similar triangles are different from congruent triangles. Okay, can anyone? I think both are same. Okay, Rahman says same. Pratik says same. Okay, but they are not. Okay, similar triangles is they are just in the ratio, equal in side angle size. Yes, psychological fact. So, in the case of congruent triangles. Okay, what? Yeah, so in the case of congruent triangles, let me just draw here, okay. So, A, B, C, P, Q, R, correct? So, in the case of congruent triangles, what happens is all angles are equal all sides are also equal. Okay, but in the case of similar triangles, the sides are in ratio. Okay, suppose these are congruent. Okay, let me draw similar triangles here. So, this is A, B, C. This is X, Y, Z. So, if it is 1, 2, 3, this will be 2, 4, 6. Okay, so the ratio. Say my name. Okay, my name is Pranati. If that's what you're asking. Alright. So, these are similar triangles. These are congruent triangles. Okay, this is the difference. Alright, now let us see and understand how do we construct a triangle similar to a given triangle ABC with its side equal to 3 by 4 of the corresponding sides of triangle ABC. Okay, so first let us see. Draw any ray BX making an acute angle with BC on the side opposite to the vertex A. Tushar. Okay. Alright, so first let us draw BX. So this is BX, correct? So let us draw a ray BX. Next, what is that? Locate 4 points B1, B2, B3, B4 and BX so that all this distance will be equal. So why are we doing 4 points? Because in the scale factor, if it is given 3 by 4, take the maximum number. Out of 3 and 4, which is greater? 4 is greater, correct? So we take 4 points on the ray BX. So again, take 1 unit or any convenient radius, place the needle of the compass at point B, then mark B1, then B2, B3 and B4. Alright. Now, this also is done. Next, join B4C and draw a line through B3 parallel to B4C to intersect BC at C dash. So, I am telling you the steps of construction as well as explanation. So, okay, please make sure after construction you write these. So, join B4C. So, what do we have to do? Join this B4C. Okay, this step is also done. What is the next step we have to do? Since it is the ratio of the scale factor is 3 by 4, correct? So, at B3, you have to draw a parallel line to line B4C. You can use the concept of corresponding angles. So, take some line, put it here, then here, okay? Then you can draw like this. So, I am just erasing this because, alright, so what do we name? We name this as C dash. Now, again we got C dash, we got BA, but we have to form a triangle. What do we do? Again, draw a parallel line A dash, C dash, which is parallel to AC. Name this as A dash. Now, A dash, B, C dash is a required triangle. Okay. A dash, B, C dash is a required triangle. So, here you can use, it's a parallel line. Okay. Just don't join anything. Okay. Use the construction of parallel lines. Construct the parallel line at point B3. Okay. So, this is how you construct a triangle similar to a given triangle when the scale factor is 3 by 4. But this is a smaller triangle we have. Okay. Alright. So, this is a smaller triangle, correct? So, let us see how to construct a bigger triangle as well. And before that, we have a doubt here in the comments. In Cartesian plane came from why some of them positive, why some of them are negative. Okay, see, there are negative numbers, right? And the set of negative numbers 0 and positive is known as integers, correct? So, just wait 1 minute, I'll just clear this doubt and we will move on, okay? So, I'm just explaining it here. So, when we take the right side numbers to be positive, the left side numbers to be negative, correct? So, if this is O where it is 0, 0, that is the origin, the right side of it will be positive, 1, 2, 3, 4, and the top side will be again positive of y-axis. I'm sure you are aware of what is x and what is y-axis, correct? And to the left of 0, that is to the left of y-axis, this is negative, so it will be -1, -2, and so on. And again to the bottom here of y-axis, it will be -1, -2, -3, and so on. So that is why in the Cartesian plane or coordinate plane where we take, there are positive and there are negative coordinates. Okay. So I hope this was your doubt and it's clear. And if you're asking why negative numbers, because you see, even in some news channels when they're telling you about temperature, you say -23. What exactly is -23, right? So this is how negative numbers came into existence, and there is so much of importance for negative numbers, okay? So when we draw a coordinate plane or x-axis, y-axis, and in the Cartesian plane, we take this like this, okay? I hope it is clear. I'm erasing this, okay, because this is not exactly the syllabus. This is just the extra thing. So let me erase this. Alright. So what are we studying? We are studying about construction of similar triangles. So here we have constructed a smaller triangle to the given triangle with a scale factor 3.4. Now let us see how to construct a triangle similar to a given triangle ABC with its side equals to 5/3 of the corresponding sides of the triangle ABC. So here we have to construct a bigger triangle to the given triangle. So let us see what are the steps of construction. It is same, okay. So draw any ray BX making an acute angle with BC on the side opposite to the vertex A. It's the same step, correct? So let us join this B. Next, locate 4. Again, here also. So here we have taken the bigger number, correct? So here what is it given? We have to take 5/3. That is, which is bigger in 5/3? 5. So we have to again locate 5 points here, correct? So the greater of 3 and 5 in 5/3. So we have to locate 5 points, B1, B2, B3, B4 and B5. So let us do it. B1, B2, B3, B4 and B5. So now you are aware, yes, very good Rahman, it's 5 points. So always you have to take the bigger number, okay? So now again I am not explaining you how to cut the arcs of B1, B2, B3 because now you are aware, right? So we are done that also. Next, so this distance should be equal. Next, join B3C and draw a line through B5 parallel to B3C, okay? Join B3C. Alright, I have joined B3C. Next, I have to draw a line through B3, that is third point Y3 being smaller of 3 and 4 in 3/4 parallel to B4. Okay, this is again we have jumped through B5 parallel to B3C to intersect BC at C dash. So again, these are the steps of construction. So you have to just follow the steps of construction to do the construction, right? There's not much to explain, but if you know how to construct, it is easier, correct? Next, what is step 4? Draw a line through C dash parallel to line CA to intersect BA at A dash. Alright, so we have stopped at this step. So let us do join B3C. Alright, I have did. Next, draw a line through B5 parallel to B3C. So just extend this, join parallel. This is C dash. Now again, extend this. And this again you have to draw parallel here. This is A dash. So A dash BC dash is a required triangle. So this all I am doing without any compass, ruler, but when you are doing, please use ruler, compass, protractor and all, okay? Next. Next is the construction of tangents to a circle. So we have seen how to divide a line segment. We have seen how to construct a similar triangle using scale factor. Now we will see how to construct tangents to a given circle. To construct the tangents to a circle from a point outside it. Now, just in the previous session, we have studied the circles chapter and seen what is a tangent, correct? So, let me explain you again. If this is a circle with center O, this PM, this is a tangent, correct? Now you are aware what is a tangent. Now we are given a circle with center O and a point P outside it. We have to construct two tangents from point P to the circle. So let us see how. Come on, we'll see it. So this is a circle with center O and this is a point P. Correct? Now what do we have to do? Let us see. We have to join PO and bisect it. What is meant by bisecting it? It is dividing the line segment into two equal halves, correct? So what is the first step? Let us join PO and bisect it. So let us bisect it. How do you bisect it? Let me tell you here. Okay. I am sure you all know how to bisect a line. So suppose this is a line AB, correct? So take more than half of length of AB, draw an arc, here also draw an arc. Again same with same radius, draw an arc here, here. Now join these. Okay. Now this line L has divided this AB into two equal halves, that is AM is to MB is equals to 1:1. Okay. Alright. So I'm erasing this, which is not needed. Okay. Alright. So join again. So please construct AM here. So here maybe somewhere it will be. Next step. Taking M as center and MO as radius, draw a circle. Let it intersect the given circle at points Q and R. Now what radius we have to take? MO as radius, and place the needle of your compass at O. Take MO as the radius and draw a circle. Okay. We have drawn a circle. Now this circle meets the first circle at points Q and R. So let us name them Q and R. Now join this PR and join PQ. Now PQ and PR are the required tangents to a circle. PQ and PR are tangents to the circle. So suppose in the question if it is mentioned, you have to take a particular radius, and construct a circle. Okay. Now let us see an example of that kind. Draw a pair of tangents to a circle of radius 5 centimeters which are inclined to each other at an angle of 60 degrees. So for this, we have to also understand few concepts of circles which we have done in the previous sessions, correct? So let us just go one by one, okay? We know that radius is perpendicular to tangent. And we also know that sum of angles in a quadrilateral is 360 degrees, correct? This is like we have been studying. So sum of angles in quadrilateral is equals to 360 degrees. Can anyone tell me what is the sum of the angles in a triangle? Because we'll be using that concept as well in few questions. What is the sum of angles in a triangle? Okay, no one. It's easy question. 180 degrees. Very good. It's 180 degrees. Good, Prati. Keep it up. You're listening. Good. So now again, let's get back to the question. 180 psychological fact. Very good. Okay, draw a pair of tangents to a circle of radius 5 centimeters. So I have already constructed this circle with radius of 5 centimeters. Okay, which are inclined to each other at an angle of 60 degrees. So first let me draw a rough sketch. Okay, so here is my rough sketch. So what it should be if I draw these tangents, okay? Suppose let me take PAB. This should be 60 degrees. Correct? This is how I should get my triangle. So what do I do? First, let us name the center as O. And let us draw a horizontal radius OR. Okay, and what is the radius? This will be 5 centimeters only. Correct? Because this is a circle of 5 centimeters. So first draw a horizontal radius. Now, if this has to be 60 degrees, I know that this is 90 degrees and this is 90 degrees. Correct? Why? Because we know that radius is perpendicular to tangent, which we have studied in our previous session of circles. So, if this is 90 degrees, this is 90 degrees, this should be 60 degrees. Can you tell me what should be the measurement of angle AOB? Come on, type the answer in the comments. Angle APB is 60 degrees and angle B angle A is 90 degrees. What is the measure of angle AOB? So type it in the comments. You can take a time of 30 seconds or 1 minute, because 30 seconds you will be getting the answer. So what concept you have to use? You have to use this. Sum of angles in a quadrilateral is 360 degrees. Let me know the answer. $120 degrees. Very good, very good. Psychological fact. SRH dude, 120 ma'am, very good. So psychological fact, I love your username, but may I know what's your name? Pratik, 120 degrees. Very good. Or it's okay, I'll call you psychological fact only. Very good, everyone. It is 120 degrees. Correct. Now what I'll do is, at this, I'll use a protractor and I will measure 120 degrees and draw this line. Okay. So this is my 120 degrees. So you can use a protractor for it. No need to Tushar. Okay, Tushar. Alright. Lovely name. So here is my 120 degrees. Now what do I know? I know that tangent is perpendicular to radius. Correct? So here I will be drawing again a 90 degrees line. So place the protractor here and measure 90 degrees. So it will be somewhere like this. Correct? This is my 90 degrees. So you can use protractor, no issues. Use protractor, measure 90 degrees at point R and draw a line. So let me just draw a line. This is ray RX. And here also you take protractor, measure 90 degrees and draw a line. So it will be around like this. This is ray QY. So when these two rays are intersecting at a point M, now our required tangents MR and MQ, and the angle between them is 60 degrees by default. Why? Because we have calculated this. So 120 plus 90 plus 90, correct? 90 plus 90, 180, 180 plus 120 is 300. So we are left with 60 degrees. So this angle will be getting 60 degrees. So this is how we have to draw this construction, because this is 5 centimeters and we also got the angle between these two tangents as 60 degrees. Okay. Now I'm sure even if hi Shabana. So even if I give you any other different angle, will you be able to construct it? Of course, yes, right? Because I know that tangent is perpendicular to radius. So for a fact, I know it is 90 degrees. And if I give you an angle between the tangents to be 45 degrees, what you will do? You will be using the concept of sum of angles in a quadrilateral and get the central angle and do with the same procedure. Correct? So I hope everyone has understood it. Do you have any doubt from the constructions, or did you understand it? I hope you have understood. Okay. So one student was asking about Cartesian plane. I hope that is also clear because I didn't. Okay, it's okay. All right. So Tushar, Pratik, SRH dude. All right. So everyone has given this correct. So you will be using the same concept to apply it. Now, let us. Okay, all right. So this is it about today's session. I know this is one of the shortest sessions we had for mathematics because, okay, thank you, Pratik. Thank you. Thank you very much. Good to hear that. So I know this is one of the shortest sessions because there are only 3 topics in constructions and I have dealt with all the 3 topics. I have taught you how to construct parallel lines and perpendicular lines and how to bisect. Correct? So please make sure these are the basics so as to proceed for the next constructions. So, okay, we are done with today's topic. So, in 45 minutes, we covered entire chapter of constructions, correct? So, I hope you have no doubt. Let us see. We have seen, what else? We have seen construction or division of a line segment in the ratio, correct? So this is the first topic we have studied. Take the ratio, sum up these 5. So take this array, divide and all we have seen. So let me just go quickly. Yeah, so we have seen one example here and we have also seen steps of construction. So make sure you write steps of construction in a very neat way because in the exam the marks specifically for steps of construction will be awarded, correct? Next, how to construct a similar triangle using a scale factor, and we have also seen what is the difference between congruent triangles and similar triangles because you've been asking a doubt from it. Next is we have seen how to construct a tangent to a circle, and this is a tangent and we have also seen how to construct it, correct? And we have seen a problem on it. So yes, this is it for today's session, and let me just tell you the schedule again because take a screenshot. Please attend, it will be useful for you. So the time slot for class 10 is 4 to 6 p.m. This is for one shot of math and science. This is for sample papers and this is for coding. All right. So yes, so next session we will be dealing with another new chapter. So yes, please attend it. Let us solve few questions also based on the topic. All right. So thank you everyone. So I'm glad even 8th class students attended and they have understood the topic very good. Okay, bye. Bye Tushar. All right.